This is a smart high-powered rocket and is powered by a motor 256 times the strength of a model rocket motor. This is the motor and is capable of propelling the rocket 9,000 feet in the air at close to 600 miles an hour. Pure power. 3, 2, 1.
Bearing 339 degrees. Distance 0.05 miles.
Let's go back to how it was built and why it was built the way that it is. For the aft section, I started with a classic Loc-EZI high-powered rocket kit. The original kit was not designed for speeds over Mach 1, so I increased the strength with a few coats of fiberglass. I then developed my own nose cone following the von Karman design since it performs well both below Mach 1 and speeds above Mach 1. 7 years ago, I realized that a smartphone had all kinds of gauges built in, so I started programming a custom app to simply record video at takeoff of a rocket and use the barometer to realize when the rocket had landed because it was back down at ground level. Since then, my app has grown and it has become full-featured. It actually tracks everything from the barometer, the accelerometer, gyroscope, and of course GPS so that I can track landing location. I even have set it up to use Gotenna, which is a 900 megahertz transmitter, so that I can get live telemetry while the rocket is airborne. In addition, I programmed a custom Arduino module that connects via Bluetooth to the smartphone and controls deployment of both the drogue and the main parachute.
Wow!
You can tell my daughter's real impressed. It's worth noting that it took several certifications to be able to fly a rocket of this much power. You want to also observe local and state laws before you attempt to do anything. The first place to start would be by contacting your local rocketry club. So we're going to make a mock demonstration as if I'm going to fly this rocket. The phone is already installed in the electronics bay. It communicates wirelessly via Bluetooth to the Gotenna device, which is then installed into the nose cone. It's installed into the nose cone. And then this seals it so that it's into its own storage compartment up in the nose cone. Now that we've got the Gotenna installed and the phone installed in the bay, I'm going to start from the back of the rocket and work my way forward. And the back of the rocket, the first thing that would have is this pyrotechnic device would be installed in the back of the rocket and secured so that it blows the drogue parachute out and forward. The drogue's purpose is to slow the descent of the rocket so that the rocket does not come down ballistic. But if I were to deploy the large parachute like this, the rocket would drift and be subjected to the wind at roughly 700 feet above the ground. The programs and the electronics that deploy the pyrotechnics necessary to deploy the main parachute, which brings the descent rate down to a safe speed where it would descend at roughly 20 feet per second. Now, you'd never want to try to catch one of these high-powered rockets. So at this point, I'm going to go ahead and start loading everything up as if I was launching the rocket. Due to the high acceleration forces, both the back and the front are secured in place by these nylon screws. When the pyrotechnic goes off in both the back and the front, is strong enough to break these screws and cause the deployment to occur. You would assemble the rocket motor as well at the field, and then the entire rocket as well as your setup would be checked by the range safety officer. The motor is then installed into the rocket and secured in place. And at this point, the rocket is ready to fly. Part of why I programmed the app was to track all kinds of telemetry. Viewing the data in sync with the launch provides valuable insight. Prepare for data overload, and let's get this thing in the air. I look forward to flying this rocket past Mach 1. I also look forward to flying it higher. So I'm working on this project. My daughter named it the Panda. It's quite a bit of custom printing, carbon fiber, and Kevlar. Roxim and OpenRocket say it will fly and be stable. What do you think? The Panda is a minimum diameter In fact, the black section is the visible motor casing. The phone slides in the white section as the phone is too large to fit inside the tube. See you next time.